Hello everybody, welcome back to the channel. We are finishing off the RF chokes and I've made a mounting for this capacitor that I'm going to be using on my mains input. This is going to be wide across the live and neutral to aid in sagging of the voltage when the coil's switched on. I've made a bracket for it to fit into, and that's going to fasten into the back like that, and then it's going to go from here onto the ballast and the neutral to each MOT. So that's that finished. Then I've made these caps for each end of my RF choke. I think the wood's mango wood. It's that cheap furniture that you get. I made the top of my table with this, and these were cut from the offcuts. So they are basically like a bung. So when I come to actually connect these, the wire will run through the center like that, and then I'll run a piece of threaded bar into there and glue it in place, and then I'll burn this enamel coating off the wire and wrap it around the bolt that's sticking out, and I'll do the same for both ends. Like that. These stoppers, I don't really need to glue them in place because I've made them nice and tight fitting, so it should go well. The bolt coming out of the bottom is going to be about this long, and that's going to go right through the bottom of the deck, and this one will be probably about yay long, and that will connect to, excuse me, well, that was a spam caller that just interrupted my video. I do apologise for that, everybody. So we're going to put threaded bar in the ends of these, and everything in the cupboard is going to be run on copper buzz bars. I've been making pieces up already, so I'm going to flatten the end, which will give me enough to put an 8mm M8 thread bolt through when I've drilled it, when it's been squashed. And then this isn't for here, but then the squashed section will fit against onto the bolt. This isn't for this is just an example. So this will be squashed. There'll be a stud through here that'll go over the stud, and the nut will go on the top, and then this will run from here to my safety, no, sorry, the top of this is going to the MOT, so the voltage will travel down here. Then I'm going to have a pipe running across the bottom to my safety spark gap. I do apologise again, that was my dog barking because there was a scrap man driving past shouting, any old iron, any old iron, so the dog started barking. But that's not a problem. She's beautiful, I love her to pieces. She's blind. She was blind from a puppy, so gone off topic now. So these are now finished. bar, I'm going to put, not these, just a piece of threaded bar into the top. You can't see, sorry. I'm going to put a piece of threaded bar into the top and then take the power from each end then. I'm waffling again, sorry. So I got my sons to lift this cupboard up for me onto these axle stands so that I don't have to bend down to fix them too much. I can just sit on my computer chair and work away on it. So the high voltage from number 1 is going to come up here to here, and it's going to run down to the bottom, and then there's going to be a threaded bar that goes through the bottom of this cupboard in here that's going to go right through the bottom. Then there'll be a copper pipe run across the bottom, and I'm going to drill a hole here, bring the copper pipe up, flatten the end and make that an electrical terminal. Obviously the same that side from here to the top, and then that's going to flow down the coil, and then another hole through the base, copper pipe run through the bottom, from there up to this bolt, then from this bolt one will go to the bottom of the rotary spark gap, which will be here, just here, and then the other one will come up and go to spark gap A, which will be at the top, or it could be at either side. I haven't decided yet. So one of the high voltage lines goes to spark gap A, and one will go to spark gap B. The other one will go to spark gap B. Then we'll tie in the MMC using a T-piece, and I will be joining the end of string 1. This is all string 1. There's 10 capacitors in this string. So string 1 will be connected to string 3, string 2 will be connected to string 4. And what I'm going to do is I'm going to use copper pipe, bring it up, take it across the back, put a T-piece in there to bring it to the spark gap, and then take it down to number 3. And then number 2 and number 4 I'm going to take underneath from there to number 4, and then I'll take a T-piece from there to go to the primary coil. So what I'm going to do for the primary coil is I'm going to bring the pipe up through the deck, attach it to the side here, no sorry here, and then I'm going to bring it up, and then I'm going to put a flexible wire from here to there so that this can be opened and closed. And then I've got to take, there we go, an earth from here, and then I've also got to earth the transformers and the spark gap. I need to run a piece of copper down through the floor of the cupboard, and then up the back of the cupboard, and then that'll go from the back of the cupboard there to the center of the secondary coil. So what I need to do now is I need to connect temporarily my MMC up and then connect it to the primary coil properly so that I can do tests on it and find out what its resonant frequency is so that I can match it with my secondary coil. So we'll be starting with quite a bit of pipe bending and figuring out how everything's going to join up. But this is the best part. So the capacitor goes behind the 3 transformers. It just helps prevent sag. And that's about it, I think. So I will come back to you when I start doing the pipe bending and everything. I think it's going to look really nice with all the copper pipe on display as well. I will keep everything well spaced, and I will insulate the copper pipe where needed, if needed. So I'd really appreciate it if you'd like and subscribe to my channel. You don't have to, but it would be appreciated if you did. So thank you for watching, and I'll see you in the next video.